Lesson 5. Inverse trigonometric functions. You'll need to understand and know how to use the inverse trigonometric functions: arc sin x, arc cos x, and arc tan x. The inverse of sin x is arc sin x, and the graph looks like this. The domain of the graph is the inputs, which goes from -1 is less than or equal to x, which is less than or equal to 1. The range of the graph goes from -pi/2 is less than or equal to arc sin x, which is less than or equal to pi/2. Or, in degrees, it would be -90 degrees is less than or equal to arc sin x, which is less than or equal to 90 degrees. And it's for real values of x. On your calculator, using the sin -1x function would give you the same principal values as the graph of y equal arc sin x from -1 to 1, from -pi/2 to pi/2. The inverse of cos x is arc cos x, and the graph looks like this. The domain of the graph is for real values of x, and again, like the arc sine, -1 is less than or equal to x, which is less than or equal to 1, because the range of cos is from -1 to 1. The range of this graph is from 0 is less than or equal to arc cos x, which is less than or equal to pi, or 0 degrees is less than or equal to arc cos x, which is less than or equal to 180 degrees. The inverse of tan x is arc tan x, and this is how the graph of y equals arc tan x would look. For the domain of the function, x can take any value from -infinity to infinity, unlike arc sine and arc cos. So we say the domain is just any real value of x. For the range of the function, we can see that it goes from -pi/2 to pi/2. So -pi/2 is less than, not less than, equal to arc tan x, which is less than pi/2. Or in degrees, is -90 degrees is less than arc tan x, which is less than 90 degrees. Because tan x is undefined at -pi/2 or pi/2, or -90 degrees and 90 degrees. As you can see, all of these inverse trigonometric functions are just their normal selves reflected in the line y equals x, because they're inverse functions. Let's do one example. Let's work out in radians the values of arc sine of -2/2, b arc cos of -1, and c arc tan of √3. For part A, solving the arc sine of -√2/2 is the same thing as solving the equation of sine x equals -√2/2 for -pi/2 is less than or equal to x, which is less than or equal to pi/2. Using your calculator, you can get x equals -pi/4 radians. To solve arc cos of -1, we can either draw the graph arc cos of x and see that -1 corresponds to pi, or we can draw the graph of y equals cos x and see that -1 also goes to pi. So, therefore, the arc cos of -1 is equal to pi radians. For part C, the arc tan of √3 is the same thing as solving tan x equals √3 for the range -pi/2 is less than x, which is less than pi/2. And using your calculator, you can get x equals pi/3. And so therefore, the arc tan of √3 is equal to pi/3. And that's about it.